All right, let's get started here. Thank you very much for coming. This is a topic I'm very excited about, and in hindsight, I thought I should have picked a more modest topic, title, but there's really so much going on as from traditional networking, think of this more as a data center, the wide area network, more and more is happening in the cloud. And what do I mean by that? My name is Nikos Anerousis. I lead the practice for consulting and implementation services at Kyndryl. We have about 400 practitioners, architects, specialists that traditionally have been working on many generations of network devices. And cloud, I think, is an incredible disruption that is happening in our industry. We have to learn how to be intelligent, productive, efficient, thinking about cloud first, cloud networking, as opposed to connecting wires in the data center. And what do I mean by that? We see that cloud is becoming the new center of gravity for enterprise network architecture. Mission critical workloads are relocating to the cloud. Companies need to master network concepts in each hyperscaler domain and center their architecture in the cloud. The whole notion of agile development, deployment, DevOps, CI/CD, mastering containers, Kubernetes, and Kubernetes networking, implementing strong security, implementing and designing around the service mesh architecture with microservices, and finally, organizing, orchestrating this together to address quality of experience. But the real reason that I'm here, forget what I just said, right? Yes, there's a monumental shift happening, but what I see as coming from a large professional services organization is the way we used to approach networking in the data center is not how we need to approach networking in the cloud. What used to be what I would call a network architect now is more like a network software engineer that needs to be proficient with different tools and different APIs. And coming to this conference, I see there is so much interesting work happening on open source projects, primarily addressing though the telco and the communication service provider domains, right? In these domains, they have some very, very complex architectures and challenges, very large networks. I am looking at this more from the perspective of the enterprise. Networks that to some extent are smaller, more perhaps even less complex, but still really important to learn how to design them and manage them, because ultimately digital business depends on the quality of the digital, of a user's, a client's digital experience. And networking is such an important component for that. So I came here to learn about how open source projects, networking open source projects, can actually address some of the issues, challenges, best practices that I have collected here when I talk about, but how do we get open source networking in the enterprise? That's my primary objective here. And by the way, if you have examples of how some of these networking projects are actually being used in the enterprise, I would be very interested to learn. So what is the main problem that I'm talking about? We know how to design networks in the data center, wide area networks, et cetera, et cetera. And now I have to go to AWS, and AWS presents to me a very different sense of structures and abstractions and constructs for creating overlays, consuming network services, managing IP addresses. And then I go to Azure, and it's a whole different domain as well, with its own challenges. And every cloud is like that. And there are some very important choices that we need to make as we start designing these networks, right? And this also departs from how network design has been done in the past. Network people, network architects, were not always involved in designing a cloud landing zone. Networking was seen as maybe an afterthought, maybe a smaller detail. And by the way, it's not just networking, right? You could say the same thing about security or resiliency, et cetera, et cetera. But as these cloud network architectures are becoming more complex, and we need to think about multiple zones, multiple regions, even multi-cloud, right? How do we design an architecture between AWS and Azure, for example, or any other clouds? You go to each cloud, and they have their own version of how they define the overlays, the so-called VPCs. How do I do IP address management is completely different in each one. Then you go into routing. How do you routing, DNS, Kubernetes networking, right? Different Kubernetes engine and APIs in every network. The security aspects, including access control lists, virtual network functions, instantiating firewalls, load balancers, and so on. How do I connect to the cloud? Do I use an SD-WAN? There are many options, the direct connect, express route, many options that I can use. How do I put everything together to support a service mesh architecture? How do I continuously optimize this in terms of cost, performance, et cetera, right? And overall, how do I enable CI/CD, DevOps, continuous design and deployment? It's a very interesting domain, and I'm going to take you through what we call some best practices for designing these networks. I'd be very, very interested to hear your feedback. And going back to the previous slide, how can we start assembling a set of open source capabilities that can help us deal with these projects? So in terms, I'm going to go through, and by the way, I've put these, I've loaded these on the website, so maybe you can download them. There's a lot of detail, what to do, what not to do, so you can look at this on your own. I'm just going to touch upon the main points here. Ultimately, we are trying to follow a set of 7 high-level principles: software-defined, automation first, workload-centric, a control plane of tools, realigning delivery teams to form a more modern operations system, zero touch in terms of configuration, and manageability. There are, in the course of, I would say, the last few years, that we increasingly started engaging or transitioning from traditional data center to cloud-centric designs. We've collected a few best practices that I want to go over with you in terms of, and by the way, this is information I harvested from our team. There's a lot of interesting detail there. Some of the detail I may not know, but I'm happy to put you in touch with our expert if you see something interesting. When it comes to macro network design in the cloud, right, I think what we've realized is that many people try to clone their data center and data center thinking into the cloud. And many times treat cloud as a DR facility. There are reference architectures out there. AWS has, Azure has, et cetera, et cetera. Following one particular architecture is a good practice, but don't always box yourself into what your hyperscaler of choice is telling you to do exactly, right? It's more important to digest a reference architecture, but in a way that you can adopt new features. You also want to communicate, have an open communication channel and the requirements between your different teams, right? Your database team, your administrators, et cetera, et cetera. Another important aspect is security standards, right? And the security landscape is changing very rapidly in the hyperscaler domain. So you need to sit down, you need to spend some more time there and try to reflect your overall enterprise security policy and how this applies into your individual security requirements, right? And how do you map enterprise policies to the architecture that you're putting together. Another important point is you want to avoid as much as possible proprietary features that are basically meant to lock you in, right? And of course, the cloud has many such lock traps with respect to how you move data, how they price your network usage, et cetera, et cetera. But there are also several with respect to, particularly having the ability, if you don't like where you sit, having the ability to move to another cloud or even back to your data center easily. And I think we've seen in the last few years, I think we've seen quite a few customers. Some customers have taken this design consideration into account and they've been able to manage this very easily. For some others, it's been really not possible and they went nowhere. So I'm going to go through some topics in no particular order here. Again, right, just accumulated knowledge from designing cloud networkings. VPC design is a really important point, especially as you're thinking about a larger cloud architecture. There are limits per account in terms of how many VPCs, how many, maybe I'm talking more AWS here, how many access control lists, et cetera, et cetera. So thinking ahead of time how you're going to map your entire universe of workloads into accounts and VPCs and doing the right service segmentation, very important point. Never max out your account limits, just in case you always have. You need some room to grow. Design for performance where needed. Spend a little bit more money on getting enhanced network interfaces as opposed to the regular options. And most importantly, design these systems for auditability, right? You will never regret including auditability in your design, right? This is where cloud, 70% of cloud security issues starts with networking, and auditability is really crucial. This is where you start debugging, tracing. This is where major incidents start, and you want to be able to trace those and start your investigation. Always include cost calculations in your landing zone design, and there's some tools out there that can help you do that. Always think in terms of scale and adopting your new features. Don't forget Active Directory integration. This is typically what most clients want to use, most enterprise clients want to use, and if you don't factor this early on, you may end up locking yourself into more proprietary products that may not serve you well, right? And DNS, of course. Identity and access management. Very, very, very important. Consider the ramifications of choosing a cloud platform-specific identity service, right? This goes back to the previous slide. AWS native versus Active Directory. Every cloud, every such function which is native to the specific cloud is a risk for lock-in and not being able to have the agility to respond later to expansion plans and so on. If you are a small business, choose the lighter plans. If you don't need to go multi-cloud, right, again, right, maybe you will also well off with the, with a native IAM solution. But for multi-cloud, your best option is Active Directory. And it's also something that you need to engineer for performance. How many lookups per second? How do you distribute this service? And how do you also use the connect functionality to serve local lookups? Do not let your IAM service become your bottleneck. Next one, another very important point, DNS. All the cloud vendors, I think, have good options. If you are in a multi-cloud environment, I think you want to use a third party. Consider also performance for if you have a lot of intranet name resolutions. Design it to be simple. Design it to be auditable and fixable. Avoid excess flows. Avoid over-engineering with disaster recovery and high availability. And also consider Anycast options, right? And there are many now cloud providers out there that offer Anycast as a service. So I didn't want to put any names here, but you know who these are. Next, wide area connectivity. This is also a very interesting domain because there are a lot of MPLS circuits there, and SD-WAN is truly needed, particularly post-COVID, where we've seen a shift in traffic patterns. Evaluate the services you need to support, right? Pivot from an IP-centric model to an API-centric model, so the backbone is software-defined, gives you that flexibility, choices of providers and connectivity options and virtual services. Challenge existing security standards that increase costs. Eliminate private connectivity where possible. You cannot do this everywhere. Design for QoS and performance. Include performance monitoring in your designs. Avoid hyperscaler-specific network functions, right? Again, right back to the topic of lock-in. Firewalls, load balancers, gateways, right? There are a lot of good vendors out there that have these as virtual functions, and these are much more portable from one domain to another. Include SASE, Secure Access Service Edge, and universal connectivity in your plans. This is especially if you are consuming a lot of software as a service and so on. Do not forget IPv6 in your design. Again, do not forget auditability. You will need it when you get hacked. Do not break your existing automation. And a lot of very good options for hyperscalers these days, providing wide area network connectivity services, right? Both AWS and Azure offer you good options. You can save money there. You can transit, and they have now all the software-defined functions and dashboards and automation in order to do that. Next one, edge landing control, right? Especially if you want multi-cloud, you need a solution to configure your network edges, right? Again, our experience, start with third-party options. Do consider your SaaS integration points, right? There's so much SaaS, right? Be it SAP, Office, et cetera, et cetera. You need to include these in your design. Use APIs as much as possible and design accordingly. Avoid complex layer 2 extensions, right? VXLANs, et cetera, riding over layer 3. So this is where overlays, control planes that exist in the data center, I think can also help you make the transition to cloud, like NSX and ACI. Be careful again with solutions that limit scalability, a lot of API call flows. And last but not least, don't max out your edge landing zones. Use a few different standards, roll them out as needed. So all of what I was talking about was, in a way, regardless, good practices, good hygiene for cloud network design. But now let's talk about Kubernetes. You want to go cloud native, an increasing number of your workloads are Kubernetes. You have a number of options with respect to plugins that allow you, that give you this observability of controllability of your containers, right, as they're deployed. There's Flannel, there's Calico, and combinations of such. What we learned, very important, network and security policies for your clusters need to be aligned with your global policies, right? You really want to avoid having a separate policy universe for your Kubernetes environments, right? And separate from your enterprise. The more that you can centrally define them and manage them and push them out, right? And propagate them all the way down to the individual pod and container level, the better you are. You know, for example, you have, all the clusters have the ability to decide, to define ACLs, routing, load balancing, et cetera, right? Make sure that you have a clear mapping of how your centralized enterprise policies are aligned there. There are also many options for managed Kubernetes environments, right? Especially if you need to move workloads from one cloud to another, that makes a lot of sense. On the other side, don't make your networking too complex, right? Try to enforce some architectural sanity down, with your teams. Don't let individual people create strange overlays, NATs, et cetera, and unnecessary complexity, but don't leave it open either, right? Don't have your machine administrators take the role of a network and security administration as well. So I think running out of time here, but let me see very quickly. I think this is more or less the last one I will talk about. You do want to consider multi-cloud. There are some good automation frameworks out there that can uniformly apply security policies, orchestrate network provisioning. Again, right, there are quite a few good vendors out there. Makes a lot of sense if you want to simplify, not only to avoid the details of each platform, but you want to simplify the management. Consider a cloud exchange if you approach, right, if you plan for future growth into other clouds. If you're using Active Directory, Azure is the best choice to have it. Other clouds, the traffic going in and out can be particularly costly. So, and if you have multiple clouds, use every cloud for what they're best at, right? Active Directory in Azure, and there are other native services for AWS and GCP equally. Avoid manual provisioning, avoid not including automation in what you do. Stick with more flexible bandwidth choices, and use cloud native services. Don't solution cloud native services in a multi-cloud design. I think this is the last one I kind of wanted to cover, right? We see a very significant evolution of the network professional. You need to have certainly people that understand cloud networking very well. You need also to have security architects there that help you, again, understand and map your security policies to every cloud domain. What is really different is what used to be very infrastructure-centric and designing leaf spines, et cetera, and have Cisco type of certifications and understanding how to set up overlays and underlays, et cetera. Everything becomes very cloud-centric. There's no more a CLI. You need to be thinking more like a software engineer. And you need to support agile development. So, with that, if you have any questions or advice or observations, I think I can finish here. Thank you. So, question for you. I went over a number of interesting design points, right, for cloud networking. In this, there's a lot of good open source, not as much as being used in the enterprise, right? What projects, what combination of projects could sort of help with, say, automation of, or orchestration of network functions or VPC design? I'd be very interested to hear your thoughts in terms of helping the enterprise consume better cloud and doing networking right in the cloud. Anyone? Okay. Well, thank you very much.